Okay, let's unpack this. Picture the vast, intricate network humming quietly beneath your city streets. Miles of pipes, unseen, yet absolutely essential, diligently ensuring our water flows and our waste goes where it needs to. It's a system so critical, so ever-present, that we rarely think about it until something goes wrong, and that's when the chaos begins. Today, we're diving deep into how digital tools aren't just improving, but fundamentally transforming the operations and maintenance, or O&M, of these vital water and wastewater systems.
Yeah, and what's truly fascinating here, and what we'll explore in depth today, is how utilities are rapidly moving beyond that reactive, fix-it-when-it-breaks mentality. We're witnessing a complete shift to a predictive, even prescriptive approach. You'll discover how data, smart sensors, and AI are now allowing utilities to anticipate issues, optimize resources, and ensure a much smoother, more resilient flow for everyone. Our source material today, coming from a fascinating set of notes and research from a recent industry conference, WaterJam 2025, gives us a really good big picture view of these cutting-edge ideas.
And for you, our curious listener who loves gaining knowledge quickly and hitting those clear aha moments, consider this your express lane. We're going to break down some complex technologies into genuinely understandable insights, offering you a clear shortcut to being well-informed on a topic that quite literally underpins our daily lives. So historically, managing these colossal networks has felt like a perpetual firefighting exercise, right?
Away.
The traditional approach, what we call reactive management, means you're always playing catch-up. A pipe bursts, a sewer overflows, and only then do you dispatch a crew to fix the immediate crisis. It's not only incredibly costly and disruptive, but it's inherently inefficient for managing such critical infrastructure.
Exactly. And that really defines one end of the O&M spectrum. You have reactive, where you wait for failure. A step up from that is preventive maintenance, where you schedule tasks at fixed intervals like cleaning pipes every 6 months, regardless of whether they actually need it or not.
Right, which might be unnecessary sometimes.
Often it is. But the real game changer, and what utilities are striving for, is moving into predictive and prescriptive operations. Predictive means using real-time condition data and sensors to forecast failures before they occur.
Okay.
Prescriptive takes it further, using advanced analytics to recommend the optimal intervention. The industry's goal here is profound, reaching that sweet spot of foresight and precision to achieve greater sustainability, resilience, and, frankly, significant cost efficiency.
Yeah.
This raises an important question for you. How much more reliably and efficiently could our infrastructure operate if we truly knew what was going to happen before it actually did?
That vision of knowing what's going to happen before it does sounds incredibly powerful. But for many, the idea of getting that kind of foresight into buried infrastructure might seem almost impossible. Where do utilities even begin to gather the data needed for that predictive leap?
That's where condition assessment comes in.
Yeah.
It's the foundational layer, essentially how utilities take a physical inventory and evaluate the current health of their buried networks. One of the most common and effective methods is CCTV inspection.
Okay, cameras in pipes.
Exactly. This involves sending robotic or push cameras directly through pipes to capture high-resolution video. This gives you incredibly detailed visual records, everything from hairline cracks and intrusive tree roots to corrosion and joint separations.
Wow.
And what's truly insightful now is how AI is automating a lot of that defect coding, assigning severity grades, often using industry standards like PACP, the Pipeline Assessment Certification Program.
So the AI does the grading.
Yeah, it helps standardize it. This isn't just about speed, it's about consistency, creating a unified understanding of pipe health that was often impossible with human inspectors working in silos. That's a huge aha moment for efficiency.
So AI can literally see the problems in the pipes and grade them for us? That's amazing.
Beyond cameras, what other techniques are being used to assess hidden issues? Well, another common technique is smoke testing.
Smoke testing.
Yeah. This is where non-toxic visible smoke is blown into sewer lines. If you see smoke seeping up through the ground, it indicates cracks, leaks, or critically illegal connections where stormwater might be entering the sanitary sewers.
Ah, inflow and infiltration, I&I.
Exactly. That I&I puts massive strain on the system during storms. Mapping these smoke test results using GIS helps utilities prioritize where to focus their rehabilitation efforts.
Makes sense.
And then we have acoustic testing. This involves using sensors that either send sound waves or passively listen through pipes to detect blockages, restrictions, or even early signs of structural issues.
Like a stethoscope for pipes.
Kind of, yeah. Think of it like a doctor using a stethoscope to listen to your arteries. It's a rapid screening tool for long stretches of pipe, And that data flows into dashboards that can trigger maintenance before a minor issue becomes a catastrophic failure.
So these are essentially diagnostic tools giving you snapshots of your network's health. Building on that, how do we turn this into something that gives us continuous real-time insights?
That's where smart sensors become absolutely essential. These are small, robust devices embedded directly into the collection systems that provide continuous real-time monitoring.
Okay, like smart home devices, but for sewers.
Exactly like that analogy.
Yeah.
Think of them like the smart devices in your home that continuously monitor everything from temperature to security. In a water utility, we're talking about various types. Flow and level sensors that detect abnormal water levels, signaling surcharging, I&I events, or impending blockages. Pressure and vibration sensors that can identify issues with pumps, or even the early stages of a pipe burst.
Wow.
Gas and water quality sensors that measure things like hydrogen sulfide, which can predict corrosion or safety hazards.
Right.
And yes, even specialized acoustic sensors that listen for the subtle sounds of leaks or early crack development in pipes.
So lots of different ways to listen in.
Yeah, the benefits are clear. You get early warnings that can prevent major incidents like sewer overflows, you collect invaluable data for hydraulic models, and you empower predictive analytics to optimize automated controls for things like pumps and valves. It's truly about turning a static, buried network into a live, measurable system.
That's incredibly powerful. It sounds like a giant leap from simply reacting to problems to actively predicting and preventing them. Our source material points to some fascinating innovations happening right now. Can you tell us more about how leading firms in the sector are bringing these powerful ideas to life?
Absolutely. We're seeing a fundamental shift here as companies develop integrated digital ecosystems rather than just isolated tools. For instance, many firms are building holistic frameworks that integrate data solutions across the entire water cycle, from initial planning and design through daily operations to long-term maintenance.
Okay.
It's essentially an overarching digital spine for managing a utility's entire water and wastewater network, ensuring all data talks to each other.
So it's not just a collection of gadgets, but a truly connected system. What kind of specific capabilities are emerging from these integrated approaches?
We're seeing powerful advancements in automation. For example, some solutions are using AI and machine learning for automated analysis of CCTV inspection video.
Right. You mentioned the AI coding.
Exactly. Instead of a human manually reviewing hours of footage, AI now identifies and codes defects and can even offer prescriptive guidance for maintenance. This significantly speeds up the process and provides consistent, objective data that was previously impossible.
I can only imagine the time savings from automating that. And how does this connect to managing the assets themselves, like the pipes and manholes?
That's where robust asset management platforms come in. These tools help utilities prioritize which pipes need attention, plan maintenance and rehabilitation, generate reinspection schedules, and assign real-time risk and condition scores to every asset.
So it helps decide what to fix first.
Precisely. And crucially, they integrate seamlessly with existing GIS and work order systems, often running nightly to keep all that condition and risk data perpetually up to date.
It sounds like these companies are building incredible ecosystems. But with so many different data sources and tools, what's the biggest challenge in making sure all that information actually talks to each other effectively? Is it getting data from older systems?
That's a critical question, because getting more from what you already have is key. Many solutions today also excel at mining data from existing sensors and systems. The idea is to extract useful signals through AI and analytics from the infrastructure utilities already possess, identifying threats before outright failures.
So using what's already there more effectively.
Exactly. It provides real-time monitoring and alerts, consolidating signals to prioritize what truly matters. It's about maximizing your current investments and ensuring every piece of data is working hard for you.
That makes perfect sense. What these examples truly highlight is a fundamental shift. We're no longer just applying digital tools to parts of the problem. We're witnessing the emergence of integrated digital ecosystems that connect every phase of water management, moving from isolated data points to a cohesive, predictive strategy. That integrated vision is the ultimate key insight.
Exactly. And if we connect this to the bigger picture, these integrated approaches are making claims of 30–40% time savings incredibly plausible.
30 to 40%, wow.
Yeah. And this isn't just wishful thinking, it's a realistic outcome, especially once these systems mature and data quality is solid. We're talking about significant efficiency gains across the board.
Those 30–40% time savings are incredibly compelling, a huge incentive. But for a utility manager listening, what's the most common obstacle they face in actually achieving those kinds of savings? And what's one piece of advice you'd give to overcome it?
That's a great point. Often, the biggest hurdle is simply data silos, getting different departments in their various systems to share information seamlessly. It's organizational as much as technical.
Right, the human element.
Exactly. My advice would be to start small, with a clear pilot project, and focus on demonstrating tangible value early on. Show how connecting just a few key data points can lead to actionable insights, and that builds internal buy-in for wider integration. Prove the concept first.
That's practical advice. So how does all this sophisticated technology translate into a Tuesday morning for a utility manager? Imagine their screen, no longer a sea of disconnected reports, but a living map, showing them the pulse of their entire network. It's a structured journey, yes, but also a fascinating story of data evolving into intelligent action.
It begins with data capture, right?
That's the start. Your smoke, acoustic, and CCTV inspections giving crucial snapshots, alongside those smart sensors providing continuous real-time monitoring.
Okay, collecting the raw info. From there, you move into automated defect coding. Modern CCTV software, enhanced by AI, automatically classifies defects using industry standards like PACP. This eliminates subjectivity and ensures consistent, reliable data.
Less guesswork.
Much less. All that data then flows into a centralized analysis platform, usually an asset management system. Here, it's scored by condition and risk and beautifully visualized on interactive GIS dashboards. This integrates critical information like cost, asset age, material, and historical failure data.
So we're building a comprehensive digital picture of the entire system, like a digital twin almost.
In a way, yeah, a dynamic representation. What happens next is this integrated data then feeds into predictive insights. AI and algorithms begin to forecast likely failures and identify hotspots in the network. This fundamentally shifts the focus from where did it break today to where will it likely break next.
Proactive, not reactive.
Exactly. This foresight then enables optimized maintenance scheduling, where risk and the potential consequence of failure dictate prioritization, ensuring those limited resources are stretched effectively.
Makes sense. Hitting the most critical spots first.
Right. And finally, there's a critical feedback loop for quality control and continuous improvement, constantly refining interventions and tracking performance. You learn what works.
This raises an important question about how we organize and visualize all this information effectively. It's about more than just collecting data. It's about making it meaningful and actionable, isn't it?
Exactly. The long-term strategy here is leveraging GIS, or Geographic Information Systems, as the authoritative asset registry.
GIS is the key then.
It really is.
Okay.
Think of GIS as the main master address book for your entire utility network. It keeps pipes, manholes, and other assets as unique entries, each with its own ID. This is the absolute key that links inspections, work orders, and that constant stream of sensor data together.
So everything ties back to the map location.
Precisely. While the time series data, the continuous readings from sensors, lives in specialized databases, maybe historians or IoT databases, it's always linked back to that GIS map, so you can see where everything is happening in real time.
So GIS truly becomes the central brain of this whole operation, connecting all the disparate pieces. But let's talk about the physical manifestation of those smart sensors we mentioned earlier. Where and how are these crucial devices actually deployed in the field? You can't just drop them anywhere, presumably.
No, definitely not. It's not just a random placement. You need a strategic network design for sensor deployment. This typically involves a baseline grid covering entire subbasins, critical coverage upstream of potential overflow sites or bottlenecks, and then an adaptive density where data indicates recurring issues. You put more sensors where the problems are.
Okay, strategic placement.
And site selection is also crucial for things like safe access for crews, minimizing vandalism, ensuring a reliable signal, and stable hydraulics. You don't want the water swirling around confusing the reading. Often, they're installed in specialized housing, sometimes called still wells, to keep the sensors stable and ensure accurate readings by minimizing water turbulence. And installation best practices involve proper mounting for ultrasonic or pressure transducers, surveying accurate reference elevations, and protection like strain relief and anti-theft hardware. Details matter.
That's incredibly detailed, and reliable data depends on reliable power, right? What's the go-to solution for keeping these remote sensors running constantly? Batteries?
Usually, yes. For power, rechargeable batteries, typically advanced lithium-ion packs at each node, are often the best choice.
Why rechargeable?
Well, this approach significantly reduces the total cost of ownership because you have fewer truck rolls for battery changes, and it offers great flexibility to adjust the sampling rate, meaning you can collect more data during storms, for example.
Ah, so you can change how often it checks in.
Exactly. These modern battery packs also enable adaptive sampling, so sensors might read every 5–15 minutes during dry weather, but ramp up to every 1–2 minutes during a storm event. Get data when you need it most. Finally, telemetry and data flow involves selecting the right communication options, often specialized wireless technologies like LTM or LoRaWAN, designed for efficiently sending small bursts of data over long distances from remote locations. Devices also have edge logic to process data locally, triggering immediate alarms for critical thresholds and ensuring data integrity with QAQC flags for flat lines or impossible rates of change.
So some intelligence is right there at the sensor.
Yes, helps manage the data flow and gives faster alerts.
And crucially, all of this data isn't just sitting in spreadsheets, is it? You mentioned GIS visualization.
Definitely not spreadsheets. It's visualized powerfully in GIS. You can literally see the health of your system on a map in real time.
That sounds like a game changer.
It really is. We're talking about map design patterns like time-enabled layers that show the last measured value, the last 24-hour maximum or peak events. The symbology can be incredibly informative. Imagine point colors indicating the percentage of pipe height occupied: green for healthy, amber for caution, red for over 70% depth.
Instant visual cues.
Exactly. Yeah. Pop-ups give instant context. A sparkline graph of the last 72 hours, the last inspection date, known defects, and even a create work order button right there on the map.
Wow, directly from the map.
Yeah. You could have thematic views like a surcharge risk map and heat map, or a reliability view showing sensor uptime and battery health. And dynamic dashboards provide key performance indicators like averted sanitary sewer overflows or the percentage of the network operating above a certain depth. It's a true game changer for situational awareness.
So we've talked about the technology, the sensors, the AI, the GIS, but what are the big operational and strategic wins here? Why is all this useful for a utility and the community it serves?
Well, for starters, you gain early warning and overflow prevention. That's huge. Rapid rise alerts trigger interventions before a sanitary sewer overflow ever occurs, preventing costly and environmentally damaging incidents.
Preventing SSOs is a major goal.
Absolutely. This leads to targeted maintenance. You prioritize lines approaching surcharge rather than simply cleaning pipes on a fixed, often arbitrary schedule. You fix what needs fixing.
More efficient use of resources.
Definitely. You get much better analytics, correlating rainfall to level rise to rank rehabilitation projects by their potential return on investment. Spend money where it makes the most difference. And it helps close the loop with inspections. Sensor-flagged hotspots can dispatch CCTV crews directly, and then you monitor post-repair trends to confirm the intervention was successful. You check your work.
And beyond the day-to-day, what's the bigger picture impact? For justifying budgets, maybe.
Yes, perhaps most significantly, it provides solid budget justification. Risk maps and documented avoided events near misses, SSOs averted, provide objective, data-driven evidence for leadership, boards, and regulators to justify continued investment.
Hard numbers help.
I do. And it fosters a profound cultural shift to proactive management, as shared dashboards and real-time data align all teams around common actionable insights. Everyone's on the same page.
That culture shift is interesting. It's critical. And those significant efficiency gains, the 30–40% time savings we discussed earlier, are realistic across many areas. From automated CCTV review and intelligent scheduling to automated reporting and more efficient field dispatch. This is the tangible ROI that justifies continuous investment.
Okay, so the benefits are clear. But this might sound like a massive, overwhelming undertaking for any utility. The good news, though, is you absolutely don't have to overhaul everything at once, right? You can start smaller.
Exactly. You can start with a minimal viable architecture, essentially a starter kit that proves the concept without breaking the bank.
A starter kit, okay. What's in it?
That's right. In the field, you begin with level sensors, maybe a mix of ultrasonic and pressure, those rechargeable battery packs, and your chosen telemetry, like cellular or LoRaWAN. In the cloud or on-premise, you'd need a time series database to store all that continuous sensor data, a rules engine for automated alerts, and an integration service to push key summaries back to your GIS.
Connecting the field to the office. Yep. Your GIS would host your core asset layers and display those sensor points with live attributes, powering web maps, operations dashboards, and mobile apps for field crews. A computerized maintenance management system, or CMMS, would then generate work orders automatically from GIS triggers, automating the workflow.
And security.
Oh yeah, absolutely critical.
Yeah.
Robust security measures for all of it, role-based access, multi-factor authentication, audit logs, standard stuff, but essential.
And the rollout roadmap is equally practical, isn't it? Not a big bang approach.
No, definitely phased. You start with a pilot project, maybe 10 to 20 manholes in a known problematic basin for about 90 days. Prove it works there first.
Test the waters, so to speak.
Exactly. Then you evaluate its alert precision, communications reliability, and battery life, tuning your thresholds based on real data. Next, you scale to your trunk network and critical laterals, integrating fully with your CMMS.
Expanding outwards.
Right. You then embed inspection linkage using CCTV after recurring alarms and tracking post-repair trends to validate the work. Make sure the fixes actually worked. Finally, you institutionalize standard operating procedures, update dashboards, and establish annual performance reporting. Make it part of the normal way of doing business.
This sounds like a very manageable path.
It is. But the process doesn't just stop once the data is flowing. We continually refine it.
Continuous improvement.
Always. That involves processing historical data, pulling years of CCTV, smoke, acoustic, and work order history into a consistent digital format. Lots of valuable info buried there. It means correcting quality issues, cleaning old data, standardizing codes, and linking assets properly. Data hygiene is crucial.
Garbage in, garbage out otherwise.
Pretty much. This all feeds into automating SOPs. When AI identifies new hotspots, standard operating procedures can be automatically revised. For example, cleaning basin A every 6 months instead of annually, based on data, not just a guess.
Letting the data guide the procedures.
Exactly. We're constantly optimizing quality control. Automated CCTV coding improves reliability, smart sensor data validates repairs, and QA/QC dashboards flag anomalies. These continuous feedback loops mean better accuracy over time. The role of AI here is pivotal. It speeds up CCTV review, detects subtle trends, recommends strategies, refines models, prioritizes work, and ultimately closes the loop as new inspections refine its predictions and auto-adjust SOPs.
So the AI learns and adapts too.
It has to.
In short, this approach shifts utilities from reactive firefighting to proactive, optimized management. The combination of clean, integrated data, AI refinement, and smart SOP updates both saves a tremendous amount of time and dramatically improves reliability, making those 30–40% efficiency gains not just possible, but demonstrably defensible.
Exactly. The message is clear. Data drives analytics, which enabled AI targeting, informs precise risk assessment, drives targeted action, and ultimately delivers a significant return on investment. These tools don't replace experienced staff. They fundamentally amplify their capacity, letting organizations make confident, proactive decisions and significantly reduce reactive maintenance.
Empowering the experts.
Precisely.
And as we just discussed, it all starts with a low-risk pilot project that proves the concept. So what does this mean for you listening? Next time you turn on your tap or flush, consider the incredible evolving digital network ensuring that smooth flow. And maybe think, what hidden systems in your own life or work, whether it's managing your personal finances, a complex project at work, or even just your daily routines, could benefit from a shift from reactive to proactive, with a little help from smart data and foresight. That's it for this deep dive. Until next time, keep exploring, keep questioning, and keep learning.